Yeah, so he was visiting professor at the University of the Pavia, Italy from 2018, and also the visiting fellow at the Tokyo University of the Japan in 2016. He is the CEO and the director of the Quantum Smart Solution Private Limited, that is the startup at the NIT Surathkal. He was a consultant also, the Start Fit Ventures Canada. He has the more than 21 years of teaching and research experience. He has supervised 8 PhD students and the 6 PhD students are working under his supervision area of satellite image processing and IoT and cybersecurity. And he has completed so many R&D projects from the different government agency as well as the private industries also. Then he has received early career award in 2017 from the Science Engineering and Research Board, Department of Science Technology, Government of India, Young Faculty Research Fellow Award in the 2019 from the Digital India Innovation Mighty from the Government of India. He is also the recipient award for the outstanding research in the area in year 2024 from the Government of the Karnataka, and he is also the guest editor of the Applied Soft Computing Journal, elsewhere publisher. He is holding the vice chair position IEEE Geoscience and the Remote Sensing Society, Bangalore, from 2021 to 23, and currently he is the chair of the IEEE, that GRSS Bangalore Society chapter from January 2024. And his area is basically the machine learning, deep learning, AI, and the remote sensing and satellite image processing, as well as the medical image processing also. Thank you, sir. I welcome you. Welcome you in the this GAN course. Just
Thank you. Thank you, Deep, for nice introduction. I hope you have learned last I think today is third day, right? Fourth day, right? So Professor, my friend, academic collaborator, so he has given you a lot more lectures and Deep, I mean, he is a core remote sensing, domain expertise. And something called as a advanced level concept, as the GAN program itself says that advances in the remote sensing, data analysis, processing, and so on. So what I will be covering in just 1 hour, I'll try to give you some insight about the advanced deep learning architectures. But before that, some very fundamental and important aspects of the deep learning which could be used for the land cover data analysis. So specifically land cover segmentation, which you can also call as a land use land cover mapping, but it's called a single object land use land cover mapping or single object land cover segmentation, or in a simple, if your algorithms side is nothing called segmentation task in broader sense. Okay. So these are my outlines. So my outlines start from introduction, but most of the fundamental already taught by Professor Fabio, so that is easy for me to, skip those contents. And then some applications of deep learning architecture, more precise only for the single object land cover mapping. Later on we'll see for multiple object in the afternoon session as well. And then few open source data set for land use land cover mapping, more specific for single object mapping task. And then for little bit neural network, but as I was listening the lecture by Professor Fabio, he has already given some thought about the neural network, then decision trees, SVM, and so on. So all the traditional machine learning algorithms, he has touched upon that. So I will not go, just one slide and few flow of my talk, how it is proceeding for the unit model finally, right? Then the deep learning model for single object land cover segmentation, so which is a focus. So start from there in a deeper sense. And then last would be the practical implementation of 2D unit CNN model for single object land cover segmentation from the remote sensing data. And then before moving, just quick introduction. So we have called computing algorithms. So computing algorithms for in general for remote sensing data analysis are as follows. So you can use meta-heuristic optimization algorithms, which last many years, I would say that last 3 decades, researchers were using for satellite data analysis, various applications, like even the land use land cover mapping use. Then the era started called artificial intelligence, where mainly your ML and DL algorithms were used. So which is currently ongoing, but future is what? What is next? Right. So next is upcoming field called quantum computing algorithms, where the focus should be quantum machine learning algorithms and quantum deep learning algorithm. For example, will be like quantum neural network, quantum CNN, and so on. Right. That will be the future upcoming areas. So then these are the prerequisites. So if you are the beginner who doesn't have any background in the deep learning area, so these are the set of knowledge you have to that acquire before jumping into the field. So as first part is called domain technical knowledge. So in domain technical knowledge, these are the your prerequisites, which basically the linear algebra, probability, statics, fundamental image processing, fundamental of even remote sensing, right, and computer visions, and then strong foundation on artificial neural network is a must. If you do not have a strong foundation on ANN, you cannot understand that the deep learning algorithms, because core of deep learning is depend on your ANN, right? Because it learn and adopt from the way ANN is learning that what the deep learning means. And then the core subjects, core research areas, mainly like application focus. For example, this GYAN program is focusing on the remote sensing, right? So remote sensing is a one core subject area where you will be finding a different type of a research problem statement, right, task. Because when you do some kind of project or your PhD work or your project or your thesis work, you need to find a good problem statement. So good problem statement comes from the domain knowledge, right, domain expertise. For example, if you want looking at some problem statement in the agriculture field, so who will give you the good problem statement? That agricultural dedicated universities, those who are working, or you need to talk to the farmer, what are the problem they are facing, and then you can get a good problem statement, right? Or then if you're looking the urban care applications, so you talk to the state government bodies, right? Or talk to the ISRO scientists, DRDO scientists. So they can give you a good problem statement. And best example of the available a good problem statement is in ISRO we have called respond basket. So if you see the respond basket, each scientist is giving the problem statement, objectives, outcomes, what are things required now. So that's ready-made problem statement. So ISRO scientist is a one source of getting the problem statement. Those who are working in that remote sensing domain, basically the NRSC, right? You have to have some good collaboration with them. It will be good to get a problem statement, lot of supports as well. Likewise, is there, and if you are looking something on the like SAR data, some like space defense application, then you need to talk to the DRDO scientists, right? So DRDO and ISRO, these are our two government bodies where have a lot more, a real problem is available with them. So you need to have good collaboration with them so that you can get good problem statement, and then later on good employment possibility will be there. Apart from this, you can see that lot more many other topics listed which don't want to touch upon this, but all other the subjects, the core area I mentioned, you can also explore in other domain as well. So when you have in your hand have a good problem statement, next objective is to find the solution, right? Finding solution is not a problem. Problem is what? Finding a right problem. So right problem is a problem, right? So once you have a right problem in your hand, solution getting is not a big task. For engineers, developing algorithms is not a big problem. As long you have that open era, now we are in open source era, right? So Python code, NumPy, all things are very easily available. You can work from anywhere, right? It's not a problem. GitHub is again the like ASEAN, C, right? Arabian Sea, right? A lot of codes are available, right? You can get that as a starter, right now. So developing algorithm in this digital era, open source era is not a problem, right? You can do that. So then you have to develop a good solutions, whatever the problem you got it in your the domain knowledge, and making a solutions, it will not take more than 3 to 4 months when you have a right problem, right data is there, right? So, and the open source like Python, NumPy, SciPy, Panda library, these are the prerequisites. You need to have a practical experience. And then OpenCV is only if you have like surveillance camera data, otherwise, right, you have like use GeoPanda library or this JIDAL library, TIFF library, others like, which is used in your remote sensing domain as well right now. Then apart from this called scikit library. Scikit library is again very important as a prerequisite because it gives you the 4 important things. One, number of ready-made data sets available for the laboratory experimentation. Second, you can do the data pre-processing because whatever the data you capture from that grounds from the field data, same data you cannot fit to the any deep learning, machine learning or deep learning algorithms. So you need to do some kind of data pre-processing, right? So like noise filtering, outlier removal, right? And then feature normalization. Feature normalization is one such a most important pre-processing as a task. So whether you use traditional machine learning or use the deep learning, data pre-processing is must, feature normalization is must, right? Because the data, whatever you capture from the source, from the field, that have a different distributions, right now. Ultimately, the data which accepted by any machine learning, deep learning algorithm should follow a normal distributions. So if data is a Gaussian distribution or uniform distribution or any other distribution, you need to convert it into a normal distribution. So that's why feature normalization is must. And there are various type of feature normalization. I'll not talk about that, but that's one aspect where the scikit library will help you to do a data feature normalizations, right? Next is called, whenever you do capture data, then also called, one-hot encoding. So one-hot encoding is again very important as a pre-processing steps. Like for example, when you capture data from the forest, right now. So like there is a called forest fire, non-forest fire, right? So the forestry person, they can give data, oh, this is a forest fire, this is non-forest fire, right? They can write that. But algorithm doesn't understand what is non-forest and what is fire, right? Algorithm understands only what? Numbers, 0 and 1, right? So if there is a called forest fire, make it as 1. If like no forest fire, make it as a 0, right? So 0, 1. Who will do? Again, the library will help you to convert forest as a 1, non-forest as a 0, right? So this part, again the scikit like label encoding, that will help you to do the one-hot encoding as a operation, as a data pre-processing, right? Apart from this, as a Professor Fabio also told, like a decision tree, random forest, support vector, all those algorithms are available in this library, ready-made, right? You can use that. But my suggestions would be, do not use any algorithm just like that. First, you need to understand a deeper about the algorithm, right? If possible, try to implement from the scratch. Try to understand all mathematical concept behind that classifier. That will be new. That will give you the understanding about the classifier. Otherwise, it will be just like black box for you, right? You are using something, but you are not aware of what you are using, right? So that should not happen especially in the engineering field, right? You should understand that, okay? So this is one part. So you can use supervised, unsupervised machine learning algorithms for solving various applications, right? Then last would be here called a deep learning library. So deep learning library, there are two popular framework is available called TensorFlow. Library is there, package, other is called PyTorch. Both are very powerful, right? And both were introduced in 2015, right? So TensorFlow package was introduced by Google R&D, whereas the PyTorch framework was introduced by the Facebook R&D, right? So both are very good. In TensorFlow, you have Keras framework, front-end implementation, and also you can use TensorFlow framework implementation, right? So it depends on you, depend on your capability, right? How much coding you want. If you want with less coding, go for the Keras framework implementation. Front end, back end will be used TensorFlow, right? And if you want more coding, you can go for a little more coding. You can go for TensorFlow framework implementation. If you still are hungry of coding, you go for the PyTorch, right? So PyTorch, you have to do a lot more coding there, right? That will demand, right? So this is one part. Last would be if you are more passionate about doing the something hardware, now you can go for the, you have like FPGA boards, right, where called ultra scale, Xilinx ultra scale boards you have. You can deploy the AI algorithms on hardware, or if you want to do something called real time also, you can go for that Raspberry Pi, or you can go for NVIDIA Jackson Nano boards. So those things you can go for hardware for implementation as well. This is just quick introduction. Prerequisite is must. I hope that got some of the other insight that which will be related to the other algorithm side as well. Then these are the three fascinating words, right? AI, machine learning, deep learning. I'll not spend much time on this, because if we spend, we will left out what the core things wanted to cover, just as a one slide to get away, like the keyword. Moving ahead, just quick introductions, right? Like in India, most of the cities we have like traffic jam. You easily see that. What about the space? Is there also traffic jam? That's also traffic jam is there, right? So I'll show you there is a traffic jam, right? And you see that currently if you see that we have in 2023 having 11,300 satellite moving in the space. So it's a big number of satellites, right? So just moving ahead, just quick about this is how like LEO, MEO, GEO, right? So that will happen the orbit where the satellite will be placed and rotating around the Earth. This is the picture. You can see there is a called traffic, right, in space. So here the dots represent nothing. These are the satellites, right? So you can think that the satellites are around that Earth is moving that, right? So future would be also this satellite should not be that collide with other satellites, right? That's another very challenging future will be. And the satellites is increasing day by day in the space right now. And the person who is a man of this satellite, Elon Musk, everybody know, he is holding 2/3 satellites in the space, that person's only, right? So he's there, right? So these are the satellites which are different applications. I'll just quickly overview, right? Use for that. And this is how satellite will observe between the space like center receptions, right? Monitoring that Earth space. These are the important questions already that has been covered by Professor Fabio, right? In the beginning only. I'll skip that, right? This all the land cover, land use I had discussed, sir. I'll just skipping that part. But here you get the information about India, right? So this is a land use land cover map of India. So you can see that, right? So this is available in India, that NRC website, right? You can see that how like map of India looks like. And if you go for the land use land cover dynamics in Bangalore city, you can see that how the city is changing, right? That built up area. So red color shade indicates that the built up area, right? So red color, if you see start from 2008 and see that 2022, right? So almost is red. That means there is no space for further the built up area come up, right? Because cover up a complete area is very problem in especially the Bangalore in India, right? Apart from in India, Bangalore is the place where whoever goes to Bangalore will never return back, right? That's the story of the Bangalore, okay? because the weather, climate is so nice, so nobody will go to their place. And then these are the details about, called all the, that, land use dynamics, Bangalore of the area, right, is how it changes, right, and different vegetations, right, like built up vegetation, water, how the vegetation is reducing, day by day, right. In fact, 2020 is reduced a lot, right. This is other in Delhi. You can see the LULC dynamics in the Delhi. Delhi is also other, kind of say that populated is that capital, right? New Delhi, where you see that again the dynamics is also changing there, right? But the way Bangalore is changed is totally, is not like a Delhi. Delhi is even less compared to Bangalore if you see that, right? So this is other in Nagaland. Not only the plain, if you the northeast also. So red color indicates that built up area. In fact, the population growth is also happening in the Nagaland northeast also. So you see that here, that started from there first A, B, C. So you can see the C figure, right, which is in 2018. So in 2018, you can see that the built up area is also increasing in the Nagaland, that northeast regions, right. Now this is here start from. So coming to the land cover mapping, so there are two kind of land cover mapping called single object land cover mapping and multiple object land cover mapping, right. So single object land cover mapping means we will be focusing only the single objects. For example, the building only, road, railway network, river networks, water bodies and so on, or forest regions from the remote sensing data. In a multiple object land cover mapping means we are looking the multiple objects together, like for example building, road, right, and then suppose they are the swimming pool or the trees, right. So multiple objects we are try to take the data, will map like different objects. That's called multiple object land use land cover mapping, right. And these are the applications which already I hope you are aware of that, where the land cover mapping will be used. And this is one such example where the deep learning will be used for the single object land covers mapping or land cover segmentation. You see the first image is here called aerial data, and the first row is called ground truth. So white region represent your road network and the black represent the rest regions, right, which is unwanted, right. And then if you see here, we called here that that mark the junctions part. So this is our algorithms, which Professor Fabio is, I think, is also part of this work, right? And these are those days, right? Only these three were the popular deep learning algorithms were available for just comparison as a set of benchmark algorithms, right? So road network you can see clearly, right, is here, and if you see other regions, there is breaks are there. But the model which we design, the network is a deep learning model able to extract the road network very effectively from this data set. Of course, this data set is not like a very good data set, but it's kind of a first data set, right, for doing a road network extraction. That's called Massachusetts road data set, right. And this is a paper link, this is a data set available. If your interest is there, you can download later on and explore. The next task is again the building network, right? Building extraction from the aerial data, remote sensing data. So again, popular data is called here Massachusetts road data set is available. I hope this data set you will be doing experiment in the lab. You will be exploring how do the building extractions as well. Yes, open available, right? It's already been shared to you guys all in the afternoon session, right? So here you see that input image, aerial data, and then called ground truth, right, which mark, and these three are the right output of the different algorithms, right. So you see here there's a simple model called FCN, fully convolutional neural networks. I'll be explaining more detail later on. And then this are the just use the different activation layers, and then this is a final output. But in this top of author use as a CRF called conditional random field as a post processing operations, right. So just for refinement of the boundary shapes, right now. And this is a paper by these authors was published. Now again interesting example, right? If I say that, right, in the Nagpur city, right? So from the center of Nagpur city, if I say that, can you count in the radius of 15 kilometers from the center of Nagpur, right? Can you count how many buildings are there manually? Possible, but you need lot more volunteers, right? Right, I hope you may require the thousands volunteers or maybe more, and just split into the different regions, and they can go and they find out how many buildings are there, right? That's possible is, but time consuming and, right, and that lot more time and more even the expensive methods, right? Now you need to hire the lot more persons, right, to do the task, right? Second would be, next is the drone data, right? So fly the drone, right, get the data, right? You can give it the AI algorithms and you can go. But again, flying drone and capturing for the 15 kilometer is not a simple task. Again, is time consuming task and even the expensive, right? Because drone, somebody has to fly, right? I may not be fly always time. You have to again get it, recharge it, and then that fly that, okay? So that's again time consuming task, right? And third and best solution is, right, you have to take the satellite data, available satellite data, right? So satellite data, just take it, give it to algorithms. Algorithms will quickly tell you how many the buildings are there in that area, right? That here, right? So why building are very important? Because from the building, if you count that and if you detect the buildings, you come to know how much area is the non-buildings, right? In non-buildings, then you come to know how many roads are there, right? How many agricultural lands are there, right? You can segregate later on. So that will help you for the city plannings, right? For that, monitoring that, all the things will be very important. So this is one such example. You can see here we have aerial data, again the Massachusetts data, and this is called here ground truth data, right? Which buildings are marked, and this is by algorithms, which our algorithms are used here. So here Professor Fabio is a part of our work as joint collaborations, right? And then see that here, whatever the kind of the accurate prediction from our algorithm is there, if you count the number of buildings in a ground truth is having 118, right? Where the algorithm which we are using DPP-net model, you can see that is giving you 119. So just a difference of one number, that's all, right? Now I mean one excess, right? Now, so if we do further fine tuning of the models, the deep learning models, we may end up with exact result. That's the power of deep learning, right? I hope that makes sense, right? Now, so integrating advanced deep learning and satellite data, all that solves many problems, right? That could be used for many applications as well. This is one core application as example of a single object as land to land cover mapping, right? Now building area, right? Likewise, you can go for multiple objects, land use land cover mapping. This is one such example where, using the road network, road building, right, and third is a backgrounds class, right, simpler task. So again, like multiple object land cover mapping, so these are the set of data, aerial data, and these are the ground truth, and this is called by O-SegNet model, which we have designed that, and you can see that this model is pretty good model, right? But not very good, but it is better than the other available algorithm when we were doing the research, right, in 2022, right? Paper was published here, right? Then moving ahead, like other models, which you see here called text data and other models and more classes like water body, rest, building and woodlands and so on. You can see that the ground truth and the kind of the prediction is there. You can see result is pretty good here, right? And then apart from the optical data, right, you can see this is called SAR data, right? So SAR data, if you see that we have aerial data, I already explained you, and this is called the output of algorithms which use like traditional machine learning, like here uses basically for random forest. Professor was teaching you morning random forest right now. So random forest used for classification, but before that, right, all the features were manually extracted and given to the random forest classifier, right. So and then this D figure is the KNN, right, K nearest neighbor algorithms classifier use, and then F is called here the your deep E is basically the SVM, support vector machine classifier, and then F is a deep lab. So you see the kind of map here, this the output, and then others. This would be pretty better than the other other methods are available right now. Okay. So from the SAR data, so you can do any kind of data, whether SAR data is there, optical data is there, right? You can do land use land cover mapping right now. Now, apart from this, if you are interested in for agriculture applications, so you see that we have called that input data, right, which is agricultural land, which comes from the crop species data set, and this is a ground truth, right? And the ground truth here, whatever is there, and this is the output of your that left side down is called the FCN Alexander model, and right side is the output of the Signet model, right? So here this just comparison, right? As a base model will come back. So black represent background, green represent your rice. Green means already RGB, right? And then your yellow is represent the corn, and then gray, right? So you can see that road. This is a road part here, right? So gray color, right? So you can do even for agriculture applications like different crop land. If you want to segregate that, the mapping also help in for agriculture application. Likewise, forestry, other field also can be explored as well. So this comes the data for remote sensing. Already the professor has talked about, but data comes from the different remote sensing here already listed, and these are the other field because I am remote sensing. Apart from I do in other field as well, right? My research, and these are the sources of data already talked about. This very important things. So whatever data is coming and the more core applications where the deep learning used for the product development, right, use mainly two important tasks, right? Mainly one broad, they are called data classifications, right? Which data classifications further divided into two types. That's called image-based classifications, and second we call pixel-based classifications, right? In a deep learning area. So here, image-based classifications, if you simple word, if you see that like forest fire, non-forest fire, right? So entire image, full image, whatever you have, belongs to either the forest fire image or non-forest fire image. Okay, I hope you understand the pixels. So intensity value of the entire image belongs to one particular class. That's called the image space right now. And like healthy and non-healthy crop, plant leaf and so on, crop classification, like different crops classification can you do, like take the pictures from the mobile, right? Build an app, give it to that, will tell that this crop belongs to wheat, whether it's a beet, corn or and so on, right? So you can do that from the image space, right? Or LUSC map updating is other examples. From that you can do that, right? Apart from this, other field also can be used, right? And then pixel based. So pixel based classification is again important, mainly as a LUSC mapping update will happen. Forest cover mapping is other example where that pixel based classification will happen, right? Landslide mapping is other important in a disaster field that will be used at, and also forest fire detection is again disaster application where you can use pixel based classifications, right? There also you can use, right, even the image piece also you can use that, right? So then other field also listed here, leave it. So this is one such example of image based classification example, right? So this entire image input is going to belongs to any one class, and here this is deep learning area, not talking much on that right now, but these are the feature extractor and this is classifier, and then mass like on which wheat and soil, right? So given input will be giving any one of the class, right? Whatever the input is giving, captured by mobile phone or the satellite, give the image, it will tell that this is which kind of class is there, right? image-based classification, right? And this is a detailed paper you can refer if you have some interest, right? You can explore. This is example called, pixel-based classifications in a simple image processing term called image segmentation, right? Task, right? So input image, and this is a unit model. I'll be exploring later on more detail. You will see the output of the model AI algorithm is here, is giving two colors. One is called pink color, other is called black, right? So pink represents the interest of our objects. Black is not our interest of the object, right? So it's a simple, binary semantic segmentation task, right? Now that's nothing else, right? You can do that. So this model can be used for simple binary segmentation or can do a multi-class semantic segment later on. I'll introduce as well. So this is a paper, right? You can read later on. Then the same algorithms, right, as I told you, can do a pixel-based classification for multiple objects right now. So this is like pixel-based classification, which already you have shown you, right, these slides. That as example of land cover mapping, right? So is nothing, it's pixel-based classification task will be used that right now. This other example, you see that land cover mapping, pixel-based, right? So input data, ground truth, and then prediction by the model. You see the multiple, classes, you can see that, right? This already you have seen that. So whatever the applications you have seen maybe earlier entire the talk, right, by the Professor Fabio also, right? Entire applications of the remote sensing, right? You can put into the three basket, right? Regression basket, regression research problem, binary classification research problem, and multi-class classification research problem, right? As far as the machine learning, deep learning is concerned right now, okay? And this task is not new. It is done by, last many decades, right now. So a real regression means very simple, a problem where you are going to predict a real value quantity. Real value quantity means that the output of a model always giving you the some numbers. For example, crop yield estimation. Crop yield estimation is the best example of the regression task in the remote sensing field, right? Is that clear? That makes sense? So crop of a field, a specific crop, will be in the tons. That's number, right? 110, 210, right? Or maybe that different numbers. So it always give you the numbers, okay? In layman terms, you can understand that when you take the pictures of your facial image, face image, right? And give it to AI algorithms. AI algorithms will tell that what is your age, right? Either give you specific age or it will tell the age of a group, right? Between the 15 to 20, right? Or 30 to 40. So from the facial image, it will tell that, right? What the exact, the age of a person. So age is a number, right? If you predicted the number like age belongs to which particular age, like child, adult, and that like next age, third last age, like that, right? So that's simple example of regression. Then binary classification examples. So we will be predicting the class which belongs to any one of the class, like yes and no task, simple word. Forest fire, non-forest fire is example, right? Healthy crop, non-healthy crop, right? Like plant leaf and all the things you can do, right? This one is example. Like building extraction is nothing, binary, right? Classification problem, right? But it's a pixel base, right? Buildings, object segmentation is like this, okay? So I hope that makes sense. Then multi-class classification research problem. So here either you will be doing a image based or doing the pixel based, right? So if you're doing image based, that means predicting one class out of more than two classes. If you're doing pixel based, predicting multiple classes, right? In the images, right? We'll be doing like land use land cover mapping. So more on the binary class, then multi-class giving the next lecture. So these are the examples, set of example where a deep learning will be used for doing the land use land cover mapping, single objects, building object, road network, river network, cloud object segmentation, right? Forest object segmentation, landslide detection, and so on, right? So these things you can see that. This is example, Now that makes sense? Single object, right? This example already you have seen that. Same example you have seen that, right? These are the available data set also there, open source, remote source data for the deep learning models which use various sources, comes from various type of data, right? And these are the links already available. The PPT will be shared, no worry, right? Dr. Deep will share you the PPT, so you have all the links access to you guys, no worry, right? Like aerial data, in that in area data is there, right? Arena data is there, then satellite image data, CBPR data set is there, cloud segment data set is there. So these are data set already available. You can just start working, right? Don't wait for that, no data set you're creating that. So first start working on the available data set. Then next step would be create a data set, create for others. That's called, always don't do users. Try to be creator, that will be always so that someone can follow you. So this is a neural network, right? So neural network here is if you are a beginner, start from the number 1 and you have to reach to the number 10 as of now. And journey from 1 to 10 is not very simple, right? It will take, you have to do some kind of sacrifices, need to spend a lot more time, right? Then only you can reach from number 1 to number 10, right? But if you are not reaching number 10, you are not up to the date, right? So you have to reach number to 10 by hook or by crooks. There is no options, right? If you want to be known in the area, right, the field, right? So like Khan network is 2024 introductions, right? So like here transformer models, attention model, all things, graph neural networks, all things you need to know, right? You should have to have a deeper understanding about these things. So I'll not talk about these things. Time is very less, right? I'm scared, right? But the flow like this, ANN, as I told you, you have to get the idea about ANN. ANN is a black box, right? Input is giving, model is there and output, right? So, but if you want it should not be black box for you. You have to understand math. Math behind activation function, math behind the derivative of activation function, math behind the loss function, and math behind the derivative of loss functions, math behind the algorithm behind the optimizer, right? So first, second, third. If you are able to understand all mathematical understanding, right, then this will not be a black box, right? So usually in my course, 1 semester course, I am teaching my university, NID Karnataka Surathkal, since 2019, right? So in a COVID time, I started the course before that, right? And I have developed myself the good content for the course for my student. Since that I am teaching as well. So I know a lot of math is there, and then you understand math, then go for the scratch implementation. Then the understanding, your thought process will be different, right? Otherwise, always scaring will be there. Oh, if something asks, what will happen, right? That should not happen. Okay, so in short here, just 1 minute thoughts. I'll give thoughts here. Activation, always use the nonlinear inside the neural network. Loss function, ideal value of the loss function should be 0, and practical value of the loss function should be close to 0. And there are how many tasks I have told you previously? Regression, binary classification, and multi-class classification, right? So there are 3 types of loss functions used are there, right? Regression loss function, binary classification loss function, and multi-class classification loss functions. There is a lot of math, right? If you want to understand that. So those ideally any loss functions, the value should be 0, practically close to 0. Question is that who will make loss close to 0? We need optimizer. So they are called gradient descent optimizers are there, which basically BGD, SGD, MBGD, ADAM, RADAM, and so on, right? You should start learning from the BGD stand for batch gradient descent. all are gradient descent optimizer, okay. Because why gradient? Because they work on the gradient, you have to compute that, right. Gradient nothing, slope you have to estimate, right now. So these are like SGD is like BGD, SGD, mini batch gradient descent, then ADAM. ADAM is used everywhere, right? ADAM optimizer, and RADAM also is extension of ADAM, and like that other optimizer also is to use that. Output layer is application specific. If you are doing regression task, output node, you have to use the linear activation. Linear activation means fz equal to z. Nonlinear activation means sigmoid, tanh, ReLU, variants of the ReLU, and so on. You can use that. Okay, that should use that. And if you are using a multi-class classification, then you have to use the softmax activations. I'll come back in my second part, right? That all those details, right? So this is one such deep neural networks, right? You have seen, right? As a deep neural network is nothing extension of ANN. Then these are the set of architectures which are used for image-based classification task. Start from the LeanNet 5, AlexNet, then your VG16, 19, GoogleNet, Inception, ResNet, DenseNet, Inception, ResNet, and so on, right? All those model which is listed over here is suitable only for image-based classification task, right? But in a remote sensing, right, there is a less task in the image base. Most of the task is on pixel base will happen right now. That will happen. I mean, as I told you, if you're doing crop based classifications, this image based classifications will be right. Right. If you're doing mapping, then it will be a pixel based classifications will happen, right? But before knowing these things, you cannot go for the mapping case, right? Like segmentation model, right? So these are the must, right? So here start from the LeanNet 5 model. So this is a model, very simple like LeanNet 5. 5 means 5 baited layer, right? Where is a bait? Here bait is that will be on the convolution layers, right? And the baits will be here your dense layer, right now. So that and one more things in a CNN, the convolution layers and then your pooling layers are responsible for the feature extraction, right now. If you forget, if you don't, because ANN or any classified traditional, we have to extract the feature and then give it that, right? So most of the time goes, feature extraction in traditional machine learning case. So to avoid those time to save that, so the researchers, what they did, before the ANN model, they put it front like called a sequence of the convolution layers followed by the pooling, convolution layers followed by the pooling, and so on, right? So these are the responsible for the different type of the feature extraction, right? They extracted from the data itself, right? So low level features and high level features, all the extraction happen through the convolution layers and pooling layers here, right? So this is other model called AlexNet. AlexNet is little is here the that deep research started from in the computer vision field from this model only, right? Which is a deep, which is called AlexNet model, which basically having the total 8 layer models. 8 layers we are called as AlexNet 8. 8 having total 5 convolution layer and 3 dense layers. So the total having the 8 baited layers. Wherever convolutions there is a bait. Wherever there is a dense layer there is a baits, right now. Okay. So bait and bias are the 2 trainable parameter in any neural networks, right now. And I'll come back later on this part. This is a way how we can compute, but that like the width and height compute at each operations. I'll come back later on. And this is basically we are moving to the size of poolings. Like width you can compute like this here, W3, W1 minus W2 plus 2P divided by S plus 1. P is basically a term called padding. Padding means whatever the input image is there, right now. So boundary we are putting just 0, 0. That's called padding, 0 padding, right now. S means stride. Stride means when you do the convolution operations, right, whether 1 unit shift is there or 2 unit shift is there or 3 unit shift is there, right? That's called stride. Okay, that's there. And you see, this is how will happen. Similarly, height, width and height compute using this formula, and output size always will be like this here, right? W3S3 into NC. NC is basically the number of channels, number of the filter used for doing a convolution operations, right? Now, theoretical concept you should be knowing that when we are doing the kernel filters, right? Now, this is basically here filters. So filters doing the operations, and the weights will be where? The filters. And this will be always a random, right, weights. And each time there will be random weights. So each time will be extracting the different weights, different features. It will not be uniform features. Because weights are the random, the features get the different, get extracted, right? Okay. So you get ton, and this is called your, the dense layer or fully connected layers, your NN part, this output softmax layer use. And before that, one operations will be called flattening operations. Always keep in mind any classifier like ANN, SBM or anything, always you have to give the data into the form of column vectors. So especially the ANN, before giving the data into this layer, you have to convert whatever the 2D matrix data is coming into a column vectors. So the operation called flattening, right? Very simple operations, right? So what will happen? The first row, put first column and column. Second row, just keep on appending that, right? That's called flattening operations. So numpy operation is there, right? You can do very quickly that. Tools are there already, right? You can help us do that. So these are the different models, right? As I start from here, pixel-based classification, FCN8, UNet, SegNet, DeepLab, attention unit, UNet plus PPL, DRNet, and SCATNet, FPNet. These are the models which can use for single object, land cover mapping, right? Land cover segmentation, right? So here, these are the models which use for the multiple objects, right? I will explain later on more detail this part, but you can see that we have come up. Green color indicates that comes from model design at our lab in IDK, and this is a model, right? A lecture model as a pictorial view, not a detailed expect the diagram. So here input data, set of convolution layers, followed by the pooling layer, max pooling, right? Convolution pooling, and so on. These are the fully connected layers, and softmax I finally get output, right? And these are the other model which already explain you, right? V6 and all things. So if we want to do a single object land use, land cover mapping, right? Or object segmentations, how we can change or convert a classification model into a segmentation model, okay? So whatever the model is available existing, this model we need to modify, which will be suitable for the land use, land cover mapping task, right? To do the task, we need to do some modifications, right? In the model, these are the existing model. So what are the modifications and why modification is needed for the land use, land cover mapping? Because if you are using the model, any classification model, because it's deep, right? When you go deeper, what will happen? Output is smaller than the input, right? So if output is smaller than input, the solution is we need to add the upsampling layer, right? If you add upsampling, we can increase the size of the image. Second is output is very coarse. You can't see object. You cannot recognize that. So the solution of this is adding the information from the previous layer. That's called skip connections. Add a fine detail from the previous layers. So we add the features from the previous so that we should be able to see the object very clearly, right now. So there are three important modifications we need to do in a available election model or any classification model is there. You can make as suitable for the segmentation task or land use, land cover mapping task. Number one, replacing the fully connected layers by a 1x1 convolution layers. Number one is modification. Number two, add a upsampling layer. Upsampling layer we have to add, right? Number three, add a skip connection from the previous layers. Okay, so we need to add from the previous layers, right, to get the more informations, right? We need to add that, okay. So these three, like as adding skip connection from the previous layer, will extract the detailed informations. So we have this called fully convolutional neural network in the sense that there is a no ANN component, only convolution layers are there, okay. That's why I call as a fully convolutional neural network, okay. Three variants we have here, this FCN32, FCN16 and FCN8, right. Apart from this called deconvolvnet, segnet, unet, which will be more focused, and then DPPnet, which comes from my lab, right. So you can use for land-use land cover mapping. So this is the example, you understand that how will mapping happen. So this is a pooling 5, right. I hope there is no confusion pooling concept, right, now here. See here, pooling 5, and if you upsample, right, what are the upsampling anyway methods are there? Traditional methods, you know, bilinear, cubic interpolation method, they have interpolation methods, right? Those are nothing used for upsampling, right? Which already know, right? You can use those also, but you can use new also, which is more advanced upsampling concept. I will be teaching you soon, right? So here I'll do the upsampling, get the like here the up 32 time do upsampling by using any methods, right? Cubic interpolation and so on. This is called here, and then this output you need to do upsampling by 2 times by using any upsampling methods. Here become 4, and from the previous, this is the pooling 4, right? Output. This is pooling 4. If you want to add this to this, cannot do add directly now. So you have to do upsampling so that both become the same shape, same size, right? And then add these 2 features and then do the upsampling task. This is called 16, FCN 16, right now. And then output of this, what we are getting this here, right? Do the upsampling 2 times, it become basically 4x4 size here, this case, and this is a 4x4 we want to. So add this with this here, and then after doing the upsampling right now. So that's why this 8, FCN 8 is always much better than the FCN 16 and FCN 32, right? You can digest visually also, and also you can do other way. This is complete, the flow here, this paper. So here if you see that pooling 4, 5, just previous I have just demonstrated the concept. This complete model part, if you see input image, convolution, pooling, convolution, pooling, convolution, pooling, convolution, and so on, right? Like this here, right? And then output of here the convolution 7, right? And this output, and the upsample into 32 times, you get this output, right? Last output, okay? But if you want to do some kind of add from the previous layers, right? What we'll do here? This output, you need to do the 1x1 convolution layers, right? And do the upsampling, and then add this part, whatever here is coming. This part cannot be added here, this. So do here, output here, there, this added, do the upsampling, right? And then add these 2 information so that you are able to do the prediction. Like the previous we have shown, previous layer, right? We are doing the adding, then doing upsampling, then finally upsampling after adding the features. After adding the features, then do the upsampling, right? So you can do here like 32, 16s, and then here you can do 8 bar also. Like if you want to, this part, we want to add features, output of here, right? But how we'll do? We cannot do directly add, okay? So you have to follow the step, do upsampling, and then only can do that part. So this is model used for image-based classifications, and then here you can do the model now suitable for doing this land-use land cover mapping, right? This is called fully convolutional AlexNet for the semantic segmentation, right now. This you see the examples, right, as a result from the research paper. So here you see that FCN 32, 16 and 8. You can see the pixel accuracy, mean IOU, and all the metrics are better than the previous 2 variants, like FCN 16, FCN 32. Okay? Look at the image, also predicted image as well here. So you see here, the image 32, 16 and 8, and this is a ground truth. So looking the picture, which one is more closer to the ground truth? Predicted output. Which one is? So now you agree with me, FCN 8 is more suitable for doing for the land cover segmentation task, right? Now, so but there is a problem. Problem with this FCN is that output is not very good, fuzzy boundaries. Okay, it's still okay, but this, see the here object, right? This is not perfectly good, right? Output is fuzzy boundary. Okay, to improve the output of fuzzy boundary of the FCN output, we have researchers has suggested the other models, come up with other models. Those models are, you can use SegNet, UNet, Deep Lab CRF, dilated convolutions and so on, right? Okay. So now this is a SegNet model that's called, SegNet means segmentation network, that's all. So here input data, so here you see that convolution, they also use batch normalization, ReLU together, and then that called poolings, then convolutions, pooling, right? And then after that this is called upsampling, right? Upsampling, and then after the upsampling they are doing again the convolutions here. So this color represents convolutions here, batch and ReLU here, 3 times, and then again 2 times upsampling here happen, upsampling, then convolutions, upsampling, convolutions and so on, right? So you see this is the output called segmentation map, right? So basically here it's matching. How many numbers here should be same match? Like this layers, like this here, pooling slices, indices, right, should match here, right? Both sides. They are not doing any like feature adding, but just exactly this is called encoder part, this is called decoder part, right? Same number of the layers, right? Using that. Does that make sense? Like what segmentation? This is the first like encoder decoder model which is used for the object segmentation or the land use land cover mapping, right? And this is the results coming from test data, ground truth, and the model which they have designed that, right? You can see that. And there's a other set of model available for comparisons, okay? Now, this also has some problems called low memory requirement during the both advantage, training and test time, but drawback is that is slower than the FCN and Deep Lab model also one is there right now. So to solution of this, again the better architecture than the SegNet is came up called UNet models. So UNet is the most popular model used for the in the remote sensing field as well as in the medical field also, right? So UNet means U-shape. UNet means U-shape, and here, how much time is there, Deep? Okay. Okay, so we'll quickly stop that, right, after a few seconds. So this model, if you see that here, right, U-shape is there, right, and then this called encoder and this called decoder. So this is called here bottleneck, right? And this bottleneck, right here, whatever you see, so input data and then 2 consecutive the convolution layer operations, blue color. So here 3 cross 3 ReLU activate convolution layers and ReLU, and then copy and this is copy and crop. So basically decoder side, what we are doing? We are adding the information from the encoder sides. So that's why the map, whatever we generate using the unit model is much better than the previous INI models like SegNet, FCN, Deep Lab, V1 and so on, right? So this is one of the, best model as far as a beginner is concerned. To start anything, you should start from the unit model. Once you learned all the process, then of course, this is not again best model, right? You have to come up with the best model which work on the multiple data set, right? Variance of the data set, right? So for that, you can design called generalization of the model, right? So here we will stop now. In the next class, next part, we'll be continuing in the some of core ideas algorithm side, which give you a lot more insight, and then we'll go for the next part as a multiple object. But once you understood this model in more insight, right, that next like multiple object extraction will not a problem, right? So 1 hour we can complete, both the things fine. Thank you. See you. Any questions there? We can take quickly one question too. Otherwise, we can have discussion during the lunch time as well, right? Okay. Of course, time is less. I need basically minimum 2 hours to complete this topic, right? Okay. Thank you.